Good day everyone, I am Junalyn A. Gongora, and for today's video, I'm going to discuss my quiz number 3 in abstract algebra entitled Isomorphism. So let us define what is isomorphism. Definition: let S star and S prime star prime be a binary structures. An isomorphism of S with S prime is one-to-one function phi mapping S onto S prime such that phi parenthesis x star y is equal to phi x star prime phi y for all x and y are elements of S. So how to show if the binary structures are isomorphic? Step 1. Define the function phi that gives the isomorphism of S. That is, we need to describe that phi of S is to be for every S is an element of S. Step 2. Show that phi is one-to-one function. That is, suppose that phi of x is equal to phi of y in S prime. Then define from this that x is equal to y in S. Step 3. That phi is onto S prime. That is, suppose that S prime is an element of S prime. Then there exists S is an element of S such that phi of S is equal to S prime. Step 4. Show that phi parenthesis x star y is equal to phi of x star prime phi of y for all x y is an element of S. For quiz number 3, we are required to construct a geometric structure which is isomorphic. So I decided to construct a square and a trapezoid. For my square, it has 5 vertices named A, B, C, D, and E, and a line segment AB, BC, CD, DE, EA, BE, and CE. And for my second figure, which is trapezoid, it has 5 vertices named A, B, C, D, and E, and a line segment AB, BC, CD, DE, EA, BE, and CE. Since the vertices and line segments of two figures are the same, then this geometric binary structure is isomorphic. And for my algebraic example, let the set of real numbers with an operation of addition where phi of n is equal to n over 3 for n is an element of R. So for step 1, let phi is a mapping of R's to R. B phi of n is equal to n over 3 for n is an element of R. So I assigned a value of n which is an element of a real number. So phi of 2 is equal to 2 over 3. Phi of 1 is equal to 1 over 3. Phi of 0 is equal to 0. Phi of negative 2 is equal to negative 2 over 3. Phi of negative 1 is equal to negative 1 over 3. And phi of negative 3 is equal to negative 1. This algebraic example satisfies our step 1. For step 2, if phi of m is equal to phi of n, then negative m over 3 is equal to negative n over 3. It implies that m is equal to n, therefore phi is 1 to 1. Then, this algebraic example satisfies our step number 2. For our step number 3, suppose that y is an element of a real number, then y is equal to m over 3 such that m is an element of a real number. Then y is equal to m over 3, then 3y is equal to m, therefore m is equal to 3y. Then phi of m is equal to m over 3 and phi of m is equal to 3y over 3, then phi of m is equal to y. Therefore, phi is onto. Therefore, this algebraic example satisfies our step number 3. And for our last and final step, let m and n is an element of a real number. Show that phi parenthesis m plus n is equal to phi of m plus phi of n. So we have m plus n over 3 is equal to m over 3 plus n over 3. Then, m plus n over 3 is equal to m plus n over 3. The phi is preserved. Then, since the expression satisfies the 4 steps, this algebraic example is an isomorphic. That's all. Thank you for watching.